In today's note, we're going to look at rearranging formulas into our equation of a line y equals mx plus b. So again, as a review or recall, the equation of a line that we've learned so far is y equals mx plus b, where m equals our slope or rate of change or rise over run or multiplier, all different terms that we have learned for that. And our b value is our y-intercept or constant or initial value. So this equation that we've learned and that we've been seeing over every note in the past so far for this unit, this equation is known as the slope-intercept form because it easily provides you with two things, and we've just talked about them, and it's in the title or the name of the form. It gives us the slope or the m value and the intercept. So this equation is important because it does give us useful information about our line. So if we look at our three examples here, we want to determine the slope and the y-intercept of the following equations. Well, my m value, again, the slope, the rate of change, the rise over run, the multiplier, it's the number that's being multiplied by the x. So in this case, my m value is negative 0.37. My y-intercept is going to be the constant or just the number by itself. So in this case, the b value is equal to negative 9.24. Again, you want to make sure you're taking the negative in front of the number, both for the slope and for the y-intercept. For b, y equals 9 over 11x plus 1 over 3. Even though we have fractions, it's still the same idea. My m is the value that's attached to the x or multiplying by the x. So in this case, 9 over 11. My b is the constant. So in this case, 1 over 3. For c, the equation y equals negative 13x minus 5 over 9. Again, it doesn't matter what the numbers are. The slope is still the number that's attached to the x or multiplying the x. So negative 13. And my b or my y-intercept is negative 5 over 9. That were the constant. So sometimes we may be given the equation of a line in another form called standard form. And the standard form is shown as below. It is shown is in the form a y plus b x equals c. And the key thing with this form is that a and b do not equal 0. So this is standard form, and computers like to spit equations of straight lines out into standard form, and it may be something you come across, but it doesn't give us any useful information. So if we're given things in standard form, we want to change it into slope-intercept form. And the reason we want to do that is because, again, we know that slope-intercept form gives us two important pieces of information that helps us understand what the line looks like. So if we're given the equation of a line 4x plus 2y equals 6, and we're asked to show that it is, or asked to change it into slope-intercept form, how would we do that? Here we can already see, I've already done it for you. Standard form is 4x plus 2y equals 6, and it's converted into slope-intercept form of y equals negative 2x plus 3. So how did we go from one form to another? Looking at the two forms, you may notice that some of the numbers do seem similar. In the slope-intercept form, we see 2 and 3, which is similar to our standard form where we had the 4 and the 6. Right? So you may see that in slope-intercept form, everything is in half or divided by 2. What you may also notice is that the x value in the slope-intercept form, or that slope, is now negative, whereas in standard form, it wasn't. So what we need to do to go from one form to another is rearrange our equation. And this is going back to some of the concepts that we learned when we solved equations back in our algebra unit. So to convert between forms, we need to use our strategies that we learned in our algebra unit, basically the opposite operations or trying to cancel things out or rearrange equations. So in example A, we want to change this equation to the slope-intercept form so that we can find some important information. So we want to get this equation, 3x plus 5y equals 3, into something that looks like y equals mx plus b. So if I look at this equation, I want to have y by itself on the left side and move everything else over. So in this case, I'm going to minus 3x from the one side to cancel it out, and minus 3x from the other side. I'm left with 5y equals 3 minus 3x. And I want to get y by itself. Right now there's a 5 being multiplied by the y. So in order to get rid of that multiplying by 5, I need to divide by 5. And I'm going to divide both terms on the other side by 5 as well. On the one side it'll cancel out, and I'll be left with y equals 3 over 5 minus 3 over 5x. Now this is now in y equals mx plus b form. Even though the slope and the x value come second, it's still in the right form. If you want, you can change it to y equals negative 3 over 5x plus 3 over 5, where all we've done is we've just swapped places or just moved one term in front of the other. Right, but both are fine. Now, if we want to figure out our slope, our m value, again, it's the number that's attached with the x. So in this case, negative 3 over 5. And our b value, or our constant, is the leftover number, or positive 3 over 5. And we can see that either way we have the y equals mx plus b form arranged, the numbers are still there. In example B, same idea. It's in standard form. I want to get it into slope-intercept form. Y equals mx plus b. So I need to get y by itself. I'm going to subtract 2x from both sides. So negative y equals 6 minus 2x. I have the negative y still. I can't forget that negative out front. And because that negative is out front, that's still making it different from y equals mx plus b. So what I need to do is cancel out that negative by subtracting negative or dividing negative 1. And I'm going to do the same thing to each term on the other side of the equal sign. It'll cancel out on one side. I'm left with y equals negative 6 plus 2x. Now I can get my slope, m value, which is the number that's multiplying the x. So m equals 2. And my constant, or the number left over, is my y-intercept, or negative 6. For C, 5x plus 4y equals 12. Same idea, I want to get it into slope-intercept form. Y equals mx plus b. I want to get the y by itself. So I'm going to minus 5x from both sides. 4y equals 12 minus 5x. Now I want to get the y by itself even further, so I'm going to divide everything by 4 on the one side, and to balance it out, I'm going to divide by 4 on the other side. Gets canceled out on the one side, and on the right side, I can simplify 12 divided by 4 nicely to 3. I'm going to leave 5 over 4 as a fraction because it doesn't reduce nicely. Now I can get my slope and my y-intercept. Again, the slope is the number that's being multiplied by the x. So my slope, or m, is negative 5 over 4. I don't want to forget that negative out front. and b is 3, or the constant. In our last example, 8x plus 12y equals 3. I want to get this into y equals mx plus b. I want to move the 8x over, so I'm going to minus 8x from both sides. I'm left with 12y equals 3 minus 8x. I want to get y by itself, so I'm going to divide, or do the opposite of multiplying. I'm going to divide by 12 and divide everything on the other side by 12 as well. It'll cancel it on the one side. I'm left with y equals 3 over 12 minus 8 over 12x. Now I can simplify this. I can reduce some of these fractions. 3 over 12 reduces to 1 over 4, and 8 over 12 reduces to 2 over 3. Now, you don't have to reduce it, but it would make it easier when you're going to draw your equation or graph your equation. So my slope is the multiplier, so negative 2 over 3, and my b is my constant, 1 over 4. So that's rearranging standard form into your equation of a line. Again, the key things are to review and remember how to solve equations, or how to rearrange equations, and we basically rearrange to get it into the form y equals mx plus b.